All right, so today we're going to be looking at how to deal with a zero on bottom whenever we take a limit. Remember, we talked about this on Friday a little bit, but option number one is to do what? Plug in. That's exactly right. If you can plug in and you get a number out, you're golden. That's what you really want to happen. However, unfortunately for you, that is not always what will happen, okay? And so Friday we looked at this. The limit as x approaches 0 of 1 over x. And does everybody remember we talked about this? And there's no other way to do this but just to kind of analyze it and think about it, right? And so remember, for a limit to exist, the left and right-hand limits have to exist and be equal. So we came to this right here. We consider the numbers that are to the left of 0, and they're really small negative numbers. And so we said if we put a really small negative in here, then 1 divided by something really small gets really big, and that a positive number divided by a negative number on the bottom would make a negative. However, on the right-hand side, plugging in a number that's to the right of 0 would be a really small positive. So 1 divided by something that's infinitely small will make your answer infinitely large. And then a positive divided by a positive makes a positive. So that one's positive infinity, right? All right, and so from that, if this is negative infinity and this was positive infinity, then we have to say that the limit does not exist, right? The limit does not exist. Go ahead, Avery. I know you want to. Okay. Then after that, we did this one right here. We said, oh, well, what happens if you take x and you square it? Well, in the same manner, we want to consider what's happening from the left-hand side and what's happening from the right-hand side. So you got to break it into both sections, right? A left hand and a right hand, in order to figure out what's happening kind of overall, okay? So with the left-hand side, if we plug a little bitty negative number in there, well, once you put a negative number in the bottom of this thing and square it, the answer is going to actually turn out to be positive, right? And so we said that 1 divided by a little bitty positive number, well, it gives you something infinitely large because the number on bottom is infinitely small, but it's positive because now you have a positive divided by a positive. Here, the limit as x approaches 0, and let me do this from the right? So we take a little bitty positive number, square it, it remains a little bitty positive number. And so 1 divided by something infinitely small will give you something infinitely large again. And just like last time, a positive divided by a positive makes a positive. Now, since these two match, we don't have to say that the limit does not exist. We can specify that this limit is actually going to infinity, okay? If they don't match, all you can say is that it does not exist. If they do match, we can say infinity. And I think that's where we made it on Friday. We got to talk about just a couple of those, right? Okay, here's a good one. Write this example down. Okay, so remember, all we're going to be doing is we're considering what's happening whenever we plug in here. And then we also want to think about just what will happen if we actually put a number into that function, right? So this function is the absolute value of x over x. So what's going to happen if we actually take a number that's really close to 0, an actual number, and plug it in there? What would we get, okay? Now, if we take this, we plug in, and what would you get? If you just plug the 0 in to start, that's always your first option, right? So you take the 0, you plug it in, what do you get? 0 divided by 0. Well, that's perplexing, right? Because 1 divided by 0, you're like, oh, that's, undefined, right? There's no way you can do that. But divide 0 by 0. Zero goes into 0 0 times, Jake. Yeah. Oh, I don't know. Because any other number divided by itself just makes what? 1. So is 0 divided by 0 1? The answer is maybe. Don't you love that? You're like, tell me that it's always 1. When I see that, I'll just put a 1 on my paper and be done. The answer is maybe. It could end up being 1. It's impossible to actually do 0 divided by 0. Okay, there's just like no real concept for that. But in terms of a limit, when you have 0 divided by 0, you could possibly get a 1 out. You could also get like 1/16 or 2 or 500. Right? There are all kinds of things. Lexi's like, what are you talking about? Mind blown, right? So in terms of 0 divided by a 0, it actually would not exist. Okay, there's no way to really do that. But Whenever we're talking about a limit, an approach of a function, this function would give you 0 over 0 if you got to that point. So the question is, where was it headed, right? Where was it going whenever we got to 0 divided by 0? Well, just like any of the other ones when we have a 0 on bottom, we want to break this one up. This one's actually unique. Usually when we have 0 over 0, we're going to do some math magic, right, and come up with an answer. But in this case, there's no way to really simplify this problem or do anything else to it. So we just have to break it into a left-hand limit and a right-hand limit. We're just using analytics here. We're just thinking abstractly about the problem, imagining things in our head to try to figure out what's going on here. What kind of numbers are to the left of 0? Negative. What kind of negative numbers? Small, really small negative numbers, right? Okay, and we can actually use a number here to help us out a little bit. So let's actually pick a number. Let's assign x a value. So a really small negative. Somebody give me a really small negative number. Well, negative 0.01. Okay, great. So let's take negative 0.01 and actually plug it into this function right here and see what comes out. Okay, so I'm going to take the absolute value of negative 0.01 over negative 0.01. We're actually going to work it out using this number. We picked something that fits kind of the description here. It's to the left of 0, yet it's approaching 0. It's really close to 0. And we can make it closer and closer and closer, right? All right. So what happens when you do the absolute value of negative 0.01? You get 0.01. And then on bottom is negative 0.01. Well, we already said before, any number divided by itself just makes what? 1. And in this case, we have a positive divided by a negative, which makes a negative. Well, what if we got even closer to 0, though? What if we picked, like, negative 0.000000001? Then what would happen? Right. So no matter what number we pick to the left, when we take a little bitty negative number and plug it into this problem right here, then what's going to happen is the top part, right, with the absolute, because of the absolute value, the top part's automatically going to switch from a negative to a positive, while the number on bottom is going to remain negative. So, but they're going to be the exact same number every time, right? And so what you get is a positive number divided by its opposite, okay? And a positive divided by a negative always gives you a negative. And the number on top and bottom is x both times. So any number divided by itself gives you 1. Yeah, so it's negative 1 on that one. Everybody see how we're just piecing these together bit by bit? Okay, now consider a number to the right of 0. What kind of numbers are over there? Positive. So now if I take that positive and I plug it into the absolute value, I get a positive. And then on bottom, there's also a positive. And a positive divided by a positive is positive. Okay? And then any number divided by itself is? Very good, Avery. So back here, we would say the limit does not exist, and it's because our left and right-hand limits don't match. Okay? And so this is the actual graph of the absolute value of x divided by x. You can see that it doesn't matter where you are, okay, on the left-hand side of 0 when you're doing the absolute value of x over x. You just have a negative number where you're going to take the absolute value of it, so it becomes positive, divided by what's still a negative number on bottom, right? And so all the way it's negative 1. And then, at 0, notice both open circles, okay? So it actually never touches that point. But then as soon as you get on the other side of 0, it just automatically appears and jumps up to being at 1 and going across, okay? So there's that one. All right, here's a good one. Go ahead and copy. And you can just copy all 3 of these down. On a quiz or a test or something like that, I may or may not have all of these written up here, right? I may just have the first one, and then you need to figure out that you should do the other 2. But remember, if you get 0 on bottom, there's going to be some more work to be done. really want the limit as x approaches 4 of 1 over x minus 4. And you can see, if we try to take that 4 on the top one and plug it in for x, we would get 1 divided by 0. Okay, so we got a 0 on bottom. Here's a problem, right? So we got to think about this thing. Well, we're going to break it into a left-hand limit and a right-hand limit, right? Okay, I'm going to use my calculator in just a second, so let me just there. Now, what kind of numbers are to the left of 4? Give me a number to the left of 4. Just think about the number line, right? So just make a number line. Here we're thinking about this. Here's 4. There's 5. Here's 3. So what would be a number just to the left? Because we're coming from the left, right? What's the number just to the left of 4? 3.99. If you want to keep, if you want to get even closer to 4, you could just keep adding 9 at the back of it, right? Okay. So what we're really gonna, so let's just consider a number right now, like 3.9, right? I'm gonna put 3.999, okay? And what's happening on bottom is that we're gonna subtract 4, right? So if you do that and you subtract 4, look what kind of answer you get out. A negative. What happens when you get closer to 4, though? What if we pick the number, because this is, it's talking about when x is approaching 4. So what if I get even closer to, I'm right here on the number line at 3.9, but what if I get even closer? What if I scoot over even more on the number line, right? It would be 3.99999 now, minus 4. What happened to my answer? It got smaller. Yeah, remember the e minus 5 means that I need to move the 5, and e negative 5 is scientific notation. It means that I need to move the decimal place 5 spaces to the left, okay? Which is actually going to give me 4 zeros, so negative 0.00001. And so the closer and closer I get to 4, if I just keep scooting over there, then the x minus 4 is just going to keep producing a smaller and smaller number, but the number is going to remain negative the entire time, right? So what's happening on bottom now is that I'm getting a really, really small negative, right? So what happens if I take this 1 right here and I start dividing it? This is what's happening here, okay? I'm taking this 1 and I'm dividing it by a negative number that is getting increasingly small on the bottom because of what's happening over here. So what happens if you take a 1 and you divide it by a little bitty number? Yeah, here's an example. 1 divided by that answer that we just got. Okay, so we're at negative 100,000, right? But if I got closer to 4, I put some more 9s on the back of my 3, then all that would happen is that my answer down here would get smaller, and then when I divide by 1 by the even smaller number, then the final answer is going to get even larger. So you see how you're just kind of connecting these things, if then, all the way through. And so we can see that this, it's a positive 1, but as long as we're to the left of 4, we're smaller than 4, so that when we subtract 4, we're going to get a negative. So a positive divided by a negative is going to make a negative, and it's going to get increasingly large, right? That side's going to go to negative infinity. I would not stray too far away. So like 3.9 or 3.99 is as far left as I would go. No, I would not. No, don't go that far away. Because what happens when you start to move really far away is, remember, if we, I use my analogy of driving back and forth to Columbus, right? But if we just left Starkville and you're headed in that direction, like there's any number of places you could be. You know what I mean? So think about it like you need to be on the exit ramp before you start trying to figure out where you're going. You can't be on 82 and be like, we're headed to Atlanta, right? Because Atlanta's a long way away. You don't really know if you're headed to Atlanta, but you do know you're approaching Columbus. You're really, really close to Columbus already. But Atlanta, you're making a lot of assumptions that you're going to pass Columbus. You're also going to pass Tuscaloosa. You're also going to pass Birmingham, and then you're going to make it to Atlanta. So what you want to do is you want to stay really close by. And that's a good question. If you tried to go all the way to the left and you say, oh, I'm going to go all the way over to -1, well, it completely changes the dynamic of the problem, right? So you got to stay in the neighborhood. You can't go way, way off. So I would say, we're thinking about things that are to the left of 4, yet very, very close to 4. Okay, good question, though. All right, So here, what's a number to the right of 4, but really, really close to 4? Okay, good. So you can see on the calculator now, if we plug in 4.001 for our x value and then subtract 4, we get a tiny number, but it's a tiny positive because we've shifted over just enough to switch it, okay? And so now this stuff on bottom is going to end up being a tiny positive number, and so a positive 1 divided by a tiny positive number is going to make a positive infinity. Now, our infinities don't match. One of them's negative, one of them's positive, so all we can say about the answer is that it does not exist. Okay? And then here's the graph for it, right? So you can see at 4, the x value 4, there's an asymptote, and then there's, from the left-hand side, it's going down. From the right-hand side, it's going up. And hopefully that's what we said. Yeah, left is negative infinity. Right is positive infinity. Okay? Avery. You can put does not exist, but some of them are going to be a little more complicated. Hopefully I have one up here. This one kind of changes things. But there's some of them where they're actually going to match. And so all you're checking for is to make sure that they're not going to be like both negative infinity or both positive infinity. And then there'll be some on a quiz or a test where I'll actually just ask you for the left hand. I'll just say, just give me the left. So that, so they're not always just, the limit does not exist. So on this one, we've just jumped straight to left hand and right hand. Now, the interesting thing about this one is, I'm trying to get you some different examples to make you really think, because you have to analyze these really well. And if the way you analyze is not very good, then you'll come out with some pretty crazy answers. And the only tricky part to this one is when I say, what is to the left of negative 4? Yeah, negative 4.001. If we were talking about positive 4, to the left of positive 4 would be 3.9999, right? So when you start dealing with negative numbers, it's like the number line kind of flips on you. So if you were looking at a number line, right, if negative 4 was here, negative 3 would be on the right and negative 5 on the left because of the nature of negative numbers, right? So when we say something to the left of negative 4, we are talking about something like negative 4.001. Right? So consider the first part right here. If we take negative 4.001 and then we add to it 4, what would be left? Yeah, the really small, the negative 0.001 is all that would be left. The 4s would wipe each other out, and the negative 0.001 is all that would be remaining, okay? And so that means that on bottom for this one, we would actually get a really small negative number. Okay, this one's actually going to produce a really small negative number. Now, what would we put on top? Notice what's up top. Not a 1 and x. So up top, we're going to put in something like negative 4.001. Okay, so you got to make sure you analyze this well, right? It'd be really easy to just assume that that's a 1 and say a positive divided by a negative makes a negative. But that's not the case because this is a negative 4. And then what kind of number did we say was on bottom? A really small negative, okay? So a negative divided by a negative now is going to make a positive number. And then what happens if you take a 4 and divide it by a really small number? It gets really, really big. If you divide a 1 by, if I have 1 pizza and I divide it into little small amounts and it makes a whole lot, right? Well, if I take 4 pizzas and do the exact same thing, it's going to make even more, right? So a 4 divided by a really, really tiny number is actually going to be a very, very big number. And so the negative divided by a negative made it positive. Now to the right of 4, so over here on the right-hand side of 4, you'll get some number like negative 3.99. So when you take negative 3.99 and you add 4, what kind of number are you going to get out? A very small positive. Okay, so now on bottom we have a really small positive number. Okay, and then up top we're subbing in the negative 4 or something really close to it. We can still use the negative 3.99, right? But on bottom we have a really, really small positive number. Okay? Now, the fact that you have a number like 3.99 and you're dividing it by something infinitely small, right, means that your answer is going to be infinitely large. And now notice that we have a negative on top, and what kind of number on bottom? So a negative divided by a positive makes a negative. Yes. Okay. Here's the next one. I'm going to pause the video for just a second and let everybody work on this one, and then I'll come back on whenever we do the answer. Okay? Okay, so hopefully you paused the video and had time to work the problems. If you didn't, you may want to do that right now because I'm going to explain them. All right, so the first one, the limit as x approaches negative 2 from the left of the function x divided by x squared minus 4. Well, if you just tried to plug the negative 2 in, remember that's always your first option. You plug the negative 2 in, and what's going to happen is negative 2 squared becomes a positive 4. And then positive 4 minus 4 on the bottom ends up giving you 0. And then you have that negative 2 up top. So if you plugged it in, it would look like this. So negative 2 up top. And then the negative 2 squared is 4. And so you have negative 2 over 0. Okay, and that's a problem. Okay, so we got a 0 on bottom with some kind of number up top. So we really need to think about this thing to try to work through it a little bit more. So what I'm going to do is I'm just going to consider a number to the left of negative 2. And sometimes it's helpful to draw a number line, right? Here's negative 2. That makes this negative 1 and this negative 3. So as you can kind of mark out where you are. In particular, it helps with the negative numbers. But to the left of negative 2, right, would be something like negative 2.001. Okay? So the important thing that happened in this problem, though, is that you actually needed to take that x value and square it, okay, before anything happened with this thing right here. So I really, in my head, just kind of want to consider what would happen if I took the number, and in my calculator, it's going to be important for me to put this in a parenthesis, right? So the number negative 2.001, and I square it, right? What's going to happen to that number? Okay, and you can see it's going to turn positive, and it's going to have a little decimal in the back once it turns positive. Okay, so we're going to have a positive number with a little decimal. But the closer and closer we get to negative 2, so if I use negative 2.00001 now, and I square that, then my decimal answer is going to get even smaller, right? But it's still positive. So what I'm actually getting here is a number that is really close to 4, but slightly larger than 4 whenever I plug these in. Everybody with me there? Okay, so I'm getting a number really close to 4, but slightly larger than 4. So if I have a number bigger than 4 and subtract 4, then I'm going to get out a positive number because this number is actually bigger than the 4. It would win the battle between the signs here. Okay, so I'm going to have a little bitty positive number on bottom. At the same time, I'm plugging in a negative number on top. In this case, it would have been, negative 2.001 or 0001. So up top, I have a negative number, and on bottom, I have a little tiny positive. So a negative divided by a positive makes a negative, and then a number, a 2 divided by something infinitely small gives me something infinitely not large, so negative infinity. On the right-hand side of negative 2 would be something like negative 1.99. So now I can consider what would happen there. Negative 1.999, and I'm going to close it, and I'm going to square it and actually see what comes out. Okay, so 3.996. Now what would happen if I got even closer, right? If I get even closer to negative 2 over here, square it. And now I have 3. Okay, and look, I have more 9s here, right? So I've gotten even closer to 4. So what's going to happen is the closer I get to 2, once I square it, my answer is going to get closer and closer to 4. So I'm really, really close to 4, but less than 4 this time. So this number right here is really, really close to 4, but less than 4. So when I take a number smaller than 4 and subtract 4, I'm going to get a negative answer out on the bottom. So a really small negative. And then up top, we have negative 1.999, okay, because that's what we were kind of using up here. And you can see sort of what would happen here. The negative, it's a negative 1.99 divided by something really small makes it really, really big. At the same time, we have a negative divided by a negative, and so our final answer would come out to be positive, right? Okay. Here's another one. Oh, yeah. Okay. So, one key difference in this problem and the last one. Okay, does everybody see that this is basically the exact same problem? What's the key difference here? Yeah, the top is actually squared. Okay, the top is actually squared, which means in both cases, what happens on the bottom is not really going to change. In the last one, we said that the bottom, from the left hand, the bottom ended up being a positive number. And whenever we worked the limit from the right-hand side, we said that the bottom ended up being a negative number, right? So for this one, the bottom will end up being a really small negative, a really small positive. The only difference is now when we take these numbers and plug them in, the top, instead of being a negative whenever we plug in, we're going to plug that negative number in and then square it, so the top is going to end up being positive in both cases. Okay? So for this one now, a positive divided by a positive would make a positive infinity, and here a positive divided by a negative would make a negative infinity. Right? So you can see the difference between that one. All it did was flip, which one was positive and which one was negative by changing the sign on top. Okay? It just changed which one was positive and which one was negative. Okay, so that's one option for what we can do. So I'm going to pause this video. That's just analyzing a graph. So whenever you get to something in particular, we'll talk more about what happens whenever you have a number, okay, a number divided by 0. You just kind of have to analyze it, figure out where your infinities are going. Remember, if the infinities match, then you can say it's positive infinity, or if they're both negative, you can say it's negative. But if they don't, you just have to talk about the limit in terms of does not exist, okay? All right, so there's that one.